So we're going to start a brand new unit here today on relationships. And it may seem kind of weird that I'm talking about relationships here in math, but the relationships I'm talking about are actually relationships between data. So is there a connection or a relationship between two pieces of data? And if so, how is that relationship described? Can I attach some math numbers to it to describe the relationship or the connection? So that's the type of relationships we're talking about in this unit, relationships between data, connections between data. And today we'll start with day one talking about scatter plots. Okay, so hopefully you might have seen scatter plots before, but that's what we'll talk about. All right, so the first thing you're going to do is actually something called a Desmos Activity. Now, some of you may be familiar with Desmos. It's an online graphing calculator, or you might have the app on your phone. So this is where you would type in equations or points and tables and dots and scatter plots, and you can do some graphing on that. Desmos is a great graphing calculator, but they also have these activities that use Desmos calculator, and that's what we're looking at here. So this is called a Desmos Activity. Okay, what you're going to need is you're going to need a code from your teacher for this specific Desmos activity. So when you get that code, you're actually going to go to student.desmos.com, and I'm going to show you how to do that. So in a moment, you're going to push pause on this video and actually complete the Desmos activity here on robots, and then come back to the video and move on with the rest of your lesson. Okay, so but don't push pause yet. I just want you to watch and how you just to see how you do this. So once you get the code from your teacher, you're going to go up to a browser. Any internet browser is going to work. I'm just going to stay in Chrome here, and you go up here and you're going to go student.desmos.com. Okay, so you type that into your browser and you'll get to this. You'll take that code that your teacher gave you and you're going to type it in and push join. Now I just have a code already preloaded here. Don't need to worry about that code, but you'll get to this screen right here. Now, here's the thing. It's on robots what a point on a scatter plot means. Okay, my name automatically pops up because I'm signed into my Google Apps account. Yours might be blank or your name will pop up. Okay, but I'd like you to type your name in here, first and last name, and then push go. Please put in your first and last name so I can know who's who. And don't put in a silly name or anything like that. I need something that I'll be able to check your progress and make sure that everything's going well. Okay, so you'll put in your name and push go. Now, I'm not going to push go because if I did, I'd be going in as a student. But when you push go, you're going to get a page that looks like this. It'll look almost exactly like this. It just won't have this stuff on the bottom. Okay, so the way these Desmos activities work is there's usually instructions at the top, maybe a title and some instructions, and then you do something on that page. So for this one, it says a warm-up, drag the points to change the robot. What do you notice? So you're going to go over to this graph and click on it and drag it across, and then you're going to see something happen. Okay, now I'm not going to take away the fun for this. You're going to go off and do this on your own. But once you go off and you play around with this, you go up here. So up in the top right, you're going to go and push next once you're done on a screen. Okay, and then there's another thing to do. So this one, again, you read the instructions at the top. Describe something you know about the robot based on your graph. So based on what you sort of played around with there, you might have an idea, and you're going to type in here, this robot is da 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 da, and then whatever you discover. Okay, when you push share with class, so after you're done typing that in, you're going to see other students' responses, so you get an idea of what other kids have written on this thing. And then once you're done this, you go push next. You'll go through, you see there's 2 of 7 slides, so you'll get through 7 activities or 7 slides here, and then you'll be done. Okay, so go off and play with this activity, and when you're done, you're going to come back to this, come back to the video and push play again. Okay, but go off to student.desmos.com and type in that code and have fun, and I'll see you back in a second. So push pause now, and I'll see you in a moment. Okay, so hopefully you enjoyed that activity, the Desmos activity, kind of a neat way to get us introduced to Desmos activities, and a fun little activity just to get used to some scatter plots and ideas on points on a graph. Okay, so now we're going to make a little bit of a note on this page here. So if you want to print this off, you could, but you don't have to. Okay, you can just watch the data and watch the information as I go through this video. Okay, so a scatter plot. So a scatter plot is a graph consisting of a set of points that show whether or not there's a relationship exists between two variables. Okay, so in our example here, I've got some data on the hours that a student plays video game and what their corresponding mark is. Okay, so I'm curious if there's a connection between these, if there's a relationship between the number of hours that you play and the mark. Okay, so you could go off and, like I said, you could print this off and actually start plotting these points, graph this data on here. Okay, or you could just grab a piece of paper and redraw this graph and do the points. You don't have to. I'm just saying you can watch the video along, but if you wanted to, you could. Okay, so I've put hours playing video games along the bottom and the mark along here. So I would take like 1.5, which is halfway between 1 and 2, and then go up to 82 and put a dot right about there. Okay, and then go to the next piece of data, do the same thing. Now, you can either push pause and do that if you want, or you can just move on to the next slide because I'm going to show you what it is. I'm going to plot these for you. So there they are. All the points, all these points are graphed on this line. So you might notice by looking at this information that it appears there's some sort of connection or some sort of relationship between the hours playing video games and the mark. That it seems to be some sort of connection. And what you can do, the line or the data seems to go down in this sort of line here. So what you can do is when you have this data, you can draw a line that represents this data. So I'm going to do that. I'm going to go take my line tool here and I'm going to sort of estimate a line that kind of represents this data. Okay, something like that. Now, some of you may know what the name of this line is. It's actually called a line of best fit. Okay, and that line of best fit represents this pattern that we see in the data. Okay, so there's some suggestions when you're making a line of best fit. You want to try and get as many of the dots above as you do below this even amount. Okay, so for example, if I had drawn it like this, you would see there's too many above the line of best fit and too many below in this one. So I've done somewhere in between. If you can get it going through a bunch of the dots, that's really, really great. But it's kind of like the average of all this stuff. Okay, and this is called the line of best fit. So that was my guess. I'm actually can get the computer to show me exactly what the line of best fit is. So let's see how I did. Oh, that looks pretty good. So if you look, I'm like bang on the line of best fit, right, going through that data. All right, so now this line represents the connection or the relationship between the hours playing video games and the mark. So we can explore this connection a little bit further. So our first question is, how would you describe the relationship between hours of video games played and the mark? So if you look at it, it seems like um, the more hours you play, the mark goes down. And that's probably not a bad assumption. The more hours you play, the mark goes down. And that's how we're going to describe this. We'll describe the bottom variable here, or the first variable in our graph, and we'll describe what it does and then how the second variable is affected by the first. Okay, so what we'll say is as the hours increase, as we go this way, as we get bigger number of hours, the mark seems to go down. So we can formalize that by saying as the hours of video games increases, the mark decreases. And there appears to be a relationship between these. That's our connection between it. Okay, and once we establish relationships, mathematical relationships, we can then go off and do all sorts of great information about it. Okay, so here's a little bit of a note. Again, you don't have to copy this down. The note is provided there, but if you wanted to, you could. So when the points on a scattered plot seem to follow a pattern, we sometimes draw a line on that graph. So ideally, and this line is used to help make predictions about the data. So ideally, the line would go through all the points, but it's very uncommon when you have a scatter plot where the points are scattered across. The next best thing is to draw a line that follows the overall trend of the data. This is called a line of best fit. Okay, and if we go back and look at ours, we see that this is a very good representation of it. If the dots are spread apart, really far apart, it's a bad representation, or it's a difficult to get pattern. But this seems to be a very good tight pattern. Okay, so this is called a line of best fit. So a couple of like the advice that I suggested, have the same number of points on either side of the line of best fit. That's very helpful. you'd like it to cross through the middle of the data, like an average of all the data. And you want to extend it beyond the actual data. So you want to go further on both ends so that you can use it to predict other data. So once that line of best fit is drawn, you can use it to interpolate or to predict information from within the given data. Okay, so I think in the data that we had before, it was like, 1 hours to 3 hours or something like that. So we could predict something in between there, like 2.5 hours or something, somewhere in between. And when we do that, it's called interpolation, okay, or interpolate the data. So you can imagine what extrapolate is. Extrapolate, of course, predicts information that is outside the data. And this is really one of the valuable things when you make these relationships is you can continue the pattern further than what the data suggests and allows you to look outside the data range. So we're going to do this in our graph here. So we're going to look at this and we're going to use the line of best fit. And it's important that we're going to use the line of best fit. I don't want you to look at the data and make predictions. We're going to use the line of best fit to predict the mark of a student who plays for 2.25 hours of video games. So 2.25 isn't on our graph, okay? But we can make a prediction based on our information, all of the data. Okay, so let's look at 2.25. So there's 2, there's 3, so 2.5 is somewhere in between here. So 2.25 is about there. Okay, and what we can do is draw a line straight up from that point till we get to our line of best fit. Not data points, but our line of best fit. Okay, and then use this information to go off and decide how high that is. So it's somewhere between 70% and 80%. I think it's closer to 80%. We can actually draw the line out here, and I would predict that it's about 78% based on all the data that's here. Okay, not based on what you just see here, because you see there's a point of 2 here that's 80 and a point of here 2 that's 76. That doesn't take into account the entire thing. The line of best fit does. So you draw it up there, and we're going to predict then that I would predict their mark would be 78%. So is this an example of interpolation, or extrapolation? And since we're looking in between the data points, that this number could be in between, this is called interpolation. And we've used it to predict that the mark would be 78%. Okay, so let's look at a second example. In the second example, I'm going to give you a percent, and I want you to decide and predict how many hours of video game this student played. So 55. So let's look at 55 is somewhere in here. And if you go across, you see that our line doesn't go that far. So even though when I drew my line of best fit, it was pretty good, it did go outside our data. We might need to extend it even further to go so that we can get more information. So I'm going to actually extend my line to go a little bit further. So it allows me to make predictions outside the range of our data. All right, so 55 is halfway in between there. So I think it's right along here. We can go here and look, and it seems to line up really nice to the 5-hour mark. So I would predict then that if they got 55%, they might have played 5 hours of video games. Okay, and since we're looking outside the given range of data, this isn't something we could have predicted by looking at the graph or looking at the table of values here. We would look at this relationship and go outside the data, and this would be extrapolation. Okay, and we go here.
So this question says you've been hired as planner for the Toronto International Airport Authority, who operates the Toronto International Airport, and the number of passengers at the airport shown. This actually happened. Now, Toronto's International Airport is really called Pearson, but this happened where they had to build another terminal. Well, you don't want to wait until you need the terminal before you build it, because you can't build it in a day. So here it says an additional terminal will be needed when the number of passengers per year reaches 100 million. It takes 5 years to build the terminal. When should they start? If we look at our graph, we know that it's absolutely positive. As the years go on, in general, more and more people are coming through because the population increases. Yeah. So it also looks like it's very much like a line. Is it perfect like a line? No, but we have to look at, if you're looking from 3 meters, 4 meters, 10 meters away, what would it look like? It would look very close to a line. It certainly doesn't look like a curve. So we want the general idea. If it looks like a line, we're going to take a ruler, and I just use the line tool here, and we're going to try and approximate the shape of the line. So for instance, if I drew it like this, I drew a positive line. But I don't think that is a good way to describe the relationship that's shown with a scatter plot. This line is far too steep. So maybe I'm going to take the line and I'm going to bring it down a little bit. Well, that looks like about the right steepness. But it's still not a great way to describe the relationship because this line is not high enough. So the idea is we'd like a line that matches the pattern of the points. We'd like as many points as close to the line as possible, but don't get hung up on, does it go through a lot of points? Are there an equal number above and below? You want to match the pattern of the points. So maybe I think the line now is a pretty good match for my scatter plot. I'm going to take my line and I'm going to extend it out until I can use it to get the information I need. So the question says, when will the population, or the number of passengers, reach 100 million? I'm going to extend my line in my pattern until I get up to 100 million. And then to see when that happens, well, often you'll see this with little dotted lines. So I'm going to just do this in green. 100 million is already marked on here, but if it wasn't, I could mark a horizontal line across. And I could similarly mark a vertical line going down. And now we could see that we're going to end up with about 100 million people in, and you'd approximate the year. It's a graph. You should get a good estimate. It may not be perfect, but you should get a good estimate. So you might say it's about 2036. Well, it takes 5 years to build it. So if we took 2036 and we took off 5 years, we should build it in 2031, or start building it in 2031. And this is how we can use data to make predictions. If it's a prediction that's outside of the data we already have, we call that an extrapolation. And it's a big idea in statistics. Use data to make predictions. They do it all the time.
But what we're going to do now is actually go off and do another Desmos activity. So this is a different Desmos activity. And it's a great little summary of all the stuff that we just learned in that little part of the video. You go off to student.desmos and try this new other activity. Once you're done, you don't need to push pause here because once you're done that activity, you're done the stuff for today. All right, that's it for now. Great, and enjoy this other Desmos activity and have a great day.